I will finish off this lesson with 3 examples of polynomial functions and finding their derivatives. The first function I'm going to find the derivative of is f of x is x cubed minus 3x squared plus 2x minus 1. The first step is to use the sum and difference rules to take the derivative of each part of this function separately. So I'm going to take the derivative of x cubed, I'm going to subtract the derivative of 3x squared, I'm going to add the derivative of 2x, and I'm going to subtract the derivative of 1. Now I'm going to take each of these derivatives separately. The next step in taking these derivatives is to use the constant multiple rule. Every derivative that has a constant times something can be written as that same constant times the derivative of what else is there. So the x cubed I'm going to leave. The 3x squared I'm going to write as 3 times the derivative of x squared. The 2x is going to be written as 2 times the derivative of x, and the derivative of 1 can be written as the derivative of x to the 0. Now I'm going to use the power rule to take each of these derivatives. The derivative of x cubed is going to be 3x squared, the derivative of x squared is going to be 2x, the derivative of x is going to be 1, and the derivative of x to the 0 is going to be 0. If we simplify this, it gives you 3x squared minus 6x plus 2. Next one, we're going to use exactly the same steps. First, we use sum and difference rules to split up this into 3 separate derivatives. It's going to be the derivative of x squared plus the derivative of 7x minus the derivative of 10. Then we use the constant multiple rule. The derivative of x squared is going to be the same. Here, the derivative of 7x is going to be 7 times the derivative of x. The derivative of 10 is going to be 10 times the derivative of 1. Then we can do the derivative of x squared. That gives you 2x. The derivative of x is just going to be 1. The derivative of 1 is going to be 0. So this simplifies to 2x plus 7. This last example, g of x is pi x to the 32 minus 7.65x squared, is basically the same as the other example. The only difference is that the constants involved here are more complicated. Pi and 7.65 are still just constants because they have no x's in them, even though they're more complicated than just a 3 or a 7. So here, when I take the derivative, first I'm going to use the difference rule. So I can take the derivative of this first part, pi x to the 32, and the derivative of the 7.65x squared separately. Then I'm going to use the constant multiple rule. We can write the derivative of pi x to the 32 as pi times the derivative of x to the 32. And the next one's going to be 7.65 times the derivative of x squared. Then I can take the derivative of x to the 32 and x squared separately. So it's going to be pi times 32x to the 31 minus 7.65 times 2x. Simplifying, this gives you 32 pi x to the 31 minus 15.3x.